Welcome to today's lecture. Today we will study the types of molecular speeds. So in these types of molecular speeds, as we have seen it, these gas molecules are present in these vessels, which these molecules having a different type of speeds. So because these speeds are not constant due to the different types of kinetic energy possessed by the individual molecules. So let us study this type of speeds given by the Maxwell, which is concluded from the Maxwell distribution comes. So these were average speed, most probable speed, that is UMP, and root mean square speed, that is URMS. What is average speed? So what average speed is? It is the arithmetic mean of various speeds of the molecule. So arithmetic mean of the various speeds of the molecules. If the gas container contains n molecules of gas, so each molecules will consist of U1, U2, U3, like that UN speed. These are the different types of speeds. So we can write U average, that is average speed of the molecule, is equal to sum of all the speeds of the molecule U1 plus U2 plus U3 up to UN divided by the n number of molecules of the speed. So here by solving we will get the average speed of the molecules. So most of the numericals is coming from these examples also. If n1 molecules are moving with speed u1 and n2 molecules are moving with speed u2 and so on, then we can again write u average equal to n1 into u1 plus n2 into u2 plus n number of molecules up to n1 into u1 speeds and divide by n1 plus n2 plus up to n1 speed. So this will be n into n1 n. So from kinetic gas equation we can get this u average equal to square root of 8 RT by pi m. So we are not going to derive this equation, just it is a derived equation, already derived equation, so just learn it by heart. So this is the u average equal to 8 RT by pi m. Next is the speed is the possessed by the molecule is, next type of speed is most probable speed. So it is a speed possessed by maximum number of molecules of a gas at a given temperature. So at one temperature, the number of molecules which gaining the maximum speed is called as a UMP, that is the most probable speed, that is equal to square root of 2 RT by m. So R is the gas constant, T is the temperature of the container, and m is the mass of the molecule. Or you can, if it is 1 mole of gas, then we can use the molar mass. So this is the 1 molar mass of this, that is UMP of the speed. That is U is the most probable speed. Next is the root mean square speed, that is URMS. What is URMS? Root mean square. This is the abbreviation of root mean square, and this is the U the speed. The speed in which kinetic gas equation PV equal to 1 by 3 m into n into v square is the hypothetical speed that we have already seen. This is the hypothetical equations in which v is the hypothetical speeds. It is possessed by all the gas molecules when the total kinetic energy is equally distributed among them. So when the total kinetic energy is equally distributed amongst them, the total kinetic energy of the n molecules of the gas is sum of kinetic energy of individual molecules. So this is the law of conservation of energy. So total kinetic energy will be equal to half m1 m into v square. So m is mass of the same molecule. Suppose one type of molecules is present in the container. So take the mass of half m v1 square, that a molecule having a different speed. Another molecule mass is same but speed is different. So in this way you take the total speed of the same molecule. Whereas v is the velocity possessed by the each of the n molecules. So total energy will be equal to number of molecules into half mv square. So equating this equation, so equate it. After equating we'll get, because this is the total number of speed by n molecules, this is the individual molecule. This is sum of the energy of the individual molecules, this is the total energy. So n into half mv square equal to half, so half mv square equal to half m into v1 square plus half m into v2 square plus up to n number of molecules. So on solving we will get v square equal to v1 square plus v2 square plus v3 square plus dash dash up to v1 square divided by n. So square root of V equal to, this is square of V1 square plus V2 square plus V3 square up to n divided by n. Then this V is actually root mean square of the gas molecule. So it is defined as square root of the mean of the squares of the speed of all the molecules present in the given sample of the gas. So now we can write this Vrms equal to in another form, that is square root of 3 RT by m, or we can write square root of 3 PV by m or 3P by rho. So these are the different derivation of these values, and these derivations we can are derived from the kinetic gas equations, which I am not going to explain again. You can see the previous lectures. Now what is the relationship between these three speed? Three speed means U average, U RMS and UMP. So speed, if you put the formula, it is root 2 RT by m. This is the average most probable speed. U average root 8 RT by pi m. So it will be your pi m, and this is your root RT by m. So just cancel root RT by m. So you will get root 2, root 8 by pi and root 3. So value of root, if you take root as a 2, if you take the value root 2 as a 2, then this will be 1.128, this will be 1.224. So this will be like this. So here we can conclude U average equal to U RMS into 0.9213, U RMS equal to U average into 1.085, and U RMS equal to UMP into 1.244. So these are the various relationships. So usually they are asking in the examination, or you can, if you remember this three value in this ratio, you can derive this ratio also. Now let us see some problems based on this molecular speeds. A sample of a gas contains 15 molecules with a speed of 3 meter per second, 25 molecules with a speed of 5 meter per second, and 30 molecules with a speed of 8 meter per second. Calculate the URMS of the molecules. URMS equal to, use this formula, N1 V1 square plus N2 V2 square N3 V3 square divided by total number of molecules. So this is the formula. So take 15 into 3 square, that is the V1 speed, for N2 25 into 5 square plus N3 30 into 8 square divided by total number of molecules 15, 25, 30. You solve it. On solving, you will get the speed 6.187 meter per second. Calculate the temperature at which, this is second question, calculate the temperature at which the average speed of oxygen equal to that of hydrogen at 20 Kelvin. So U average equal to 8 RT by pi m. So this will give you 8 R into 20 by pi into 2, because the molecular mass of the hydrogen is 2. So on solving, 8 RT by pi m. So this for hydrogen, this for oxygen. So root will be cancelled. We will get 20 by 2 T by 32. So T equal to 320 Kelvin. Next question. Calculate the URMS, U average, UMP of the carbon dioxide molecules at 700 Kelvin. So you have to find out this thing. Already temperature is given, molar mass you know that, you can solve it, and value of R you know very well. So URMS of this is 3629, U average will be 550, and UMP will be 514. Just you solve by yourself. This is up to you.